this video we're going to continue talking about groundwater sampling by covering well construction and hydraulic testing. So when we talk about well construction, really what we're focusing on is minimizing the influence of how you drill the wellbore and the wellbore on your sample, and on having the right type of drilling equipment for your geology, and on screening or allowing interaction between your target formation and your wellbore. And I'll show you diagrams of that in a moment. So it's really important when drilling to not have the drilling mechanisms affect your results. So avoiding leaking oil, cleaning the drill rig between sites, and keeping the drill rig clean while you're at site will help minimize contamination of your wellbore. And then choosing the right drilling equipment based on the geology, the depth, and the target analytes. Really, you're trying to aim to minimize disturbance of the drilling method on your results. So I invite you to pause this and look at any of these YouTube links for more information on how these types of drills work. But very basically, the three most common methods for drilling groundwater monitoring wells are augers, cable tools, and rotaries. Augers basically look like screws, and they're useful for shallow, unconsolidated material. So unconsolidated material isn't rocky yet. It's things like more like a soil texture for a shallow well. A cable tool can be used for deeper bores or for consolidated bores, and are typically pretty cheap to use and only need one or two people to operate, but they're pretty slow. Rotaries are more what you think about with the larger drill bit on the head, rotating with a shaft that require a fluid to run, and those can be run with both air or mud. And these are typically used for a lot of the deeper bores. So all I'm showing here is a relationship of the geologic environment generally to what type of drilling technique can be used. So what you can see is that for most cases there are multiple options, and so it'll depend on what company's drilling, what your budget is, what's available in your area. These are just a couple of diagrams that will help us talk about how these wellbores are actually constructed and what they look like when they're completed. So wellbores are going to be cased, typically with PVC. And so this is showing a 2-inch PVC casing with a 2-inch slotted screen. And so this screen portion is the portion that's going to allow water in and out of your wellbore. And you can see here that there's a slotted casing marked in this diagram as well. In this diagram, what we can see is that there's sand and gravel around this casing in the lower portion. And that's the portion that's going to allow water to go from the rock and into the wellbore, or from the wellbore and into the rock. So this is the portion that would be considered our target portion. And then there's bentonite, which is a clay that's going to stop water from moving in and out, soil and concrete that are isolating these portions of the well and the surface from the portion that's allowing water in and out. And then we put a well protector over top of the well to keep it from getting mowed over or vandalized or destroyed in some other way. This one's a very similar situation. You have a cement seal underneath the well to keep water from moving up. We have gravel around a slotted casing in the target aquifer. We then have cement or bentonite isolating the target aquifer from everything that's above it, and a concrete plug at the top. We then have a shield over top of it, again, to stop vandalism or destruction in some other way. Right, now we're going to talk about hydraulic testing. There are several main things that we target when we're looking at groundwater monitoring, and one of them is actually determining the hydraulic parameters of the aquifer. So we spoke in an earlier video about hydraulic conductivity, and so these are methods that would allow us to determine hydraulic conductivity and other similar parameters. So they can either be conducted with a single well or multiple wells. So we'll talk through each of these. We'll talk about single well slug tests, single well packer tests, and multi-well pumping tests. So in a slug test, water is either rapidly added to or removed from a wellbore, and the change in water level and the rebound or the return of the water level to a normal level is recorded. Because these can be pretty minor changes in water level, it's highly recommended that a water level logging instrument is used to measure the change in water level, to actually detect and be able to quantify how that water level changes and how long it takes to return to normal. And so typically, and this usually doesn't take too long, but you know, sometimes it does if you have a low hydraulic conductivity. The test should continue until the water is to 80 to 90% of normal, so that it's almost back to normal. So really we want to either add a bunch of water or remove a bunch of water and see how long it takes to get back to normal. With a packer test, this is just basically a version of a slug test where we're isolating different parts of the wellbore for that slug test. And these inflatable packers are used to isolate them. So imagine inflatable balloons that will seal off the wellbore and allow you to just test a portion of it. So if you're testing the bottom portion of a well, you use an inflatable packer with a pipe through it that isolates just the bottom portion. And if you're testing the middle of a well, you'll use two, so one below and one above, and test in between them. And so this is going to be a similar setup to a slug test, but you're isolating parts of the bore so that you can really have a better understanding of what's happening at different depths. With a pumping test, you're doing something similar, but you're using multiple wells. So you'll have your pumping well, and you'll pump water at a constant rate, usually for about 2 to 4 hours out of that well. And you'll monitor the water level changes at multiple observation wells at known distances away. And from that, you can calculate the hydraulic conductivity of the aquifer. In general, pumping tests are going to be more expensive but more accurate than slug tests or packer tests. So in this video, we talked about basic well construction and hydraulic tests for groundwater. Thank you for listening.